Alright, number 15, section 13.6. Profit, once again. A manufacturer can produce at most 120 units of a certain product a year. The demand equation for the product is P equals Q squared minus 100Q plus 3200. And the manufacturer's average cost function is 2/3 Q squared minus 40Q plus 10,000 Q. 10,000 over Q. Determine the profit maximizing output and the corresponding maximizing profit. Alright, so let's turn these functions into the ones we need. This is going to be revenue first. Revenue is going to be price times quantity, so we're going to get Q cubed minus 100 Q squared plus 3200 Q. Then we need to turn this one into the average cost and the total cost by multiplying it by quantity as well. We're going to get 2/3 Q cubed minus 40. Sorry, this is 40Q, so minus 40Q squared plus 10,000. Alright, so profit is going to equal revenue minus costs. Q cubed minus 100Q squared plus 3,200 Q minus 2/3 Q cubed minus, so we're subtracting this entire function, so minus negative 40 is plus 40Q squared minus 10,000. Let's combine like terms. 2/3 Q cubed plus 1Q cubed is going to equal 5/3 Q cubed. Then we've got negative 100Q squared plus 40Q squared, so we have negative 60Q squared plus 3,200Q minus 10,000. And now we're going to take the derivative with respect to quantity. Multiply this by 3. We're left with 5Q squared minus 120Q plus 3,200. Let's factor out 5. Q squared minus 40, sorry, 40, no, wait, 24, I'm tired, 24Q plus, into 3,200, 5 goes, let me see, that's 640 times 5 will get us 3,200. Alright, so now we need to factor this equation to get the critical values. 5 times, so 64 is 8 times 8. Let me see, I'm just going to cheat here. Okay, I've almost got it. Minus 2/3. Oh, I screwed up. So here, Q thirds minus 2/3 Q3 is going to equal 1/3 here. So this is 1/3. So when I take the derivative, it's 3 times 1/3 q cubed. So I'm looking at the q cubed term. 3 times 1/3, the 3's drop out, and so d pi dq is actually equal to q squared minus 120 plus 3200. So factoring out a 5 is out of the question. So we're back where we kind of started from. So 3200, 80 times 40. Yes. So q minus 80, q minus 40. So minus 40 minus 80, multiply to 3200 and add up to 120. That factor is right. Set that equal to 0. So our critical values are q equals 80 and 40. So now we need to see what our second derivative is at each of these values in order to identify the maximum. So let's take the second derivative. d2 pi over dq2 is going to equal 2q minus 120. If we plug in 80 for q, we're going to get 160 minus 140, which is going to give us a positive value. So this is a minimum. A positive value means that we have concave up, so 80 is a minimum. Let's plug in 40. 40 times 2 is 80 minus 120 is negative 40. So the second value at the second derivative is going to leave us with a negative, thus implying the function is concave down, making 40 a maximum. So now we have the number we need for number 15. 40 is a maximum. And all we need now is the corresponding, we need to figure out the maximum profit. So we need to plug in 40 into our profit equation. So pi equals 40 cubed. I'm looking here. Our profit equation. So it's 1/3 q cubed, so 40 raised to the third power times 0.33333 is 21,333.31 minus 60q squared. 60 times 1600. 96,000. So minus 96,000 plus 3,200 times 40 plus 128,000 minus 10,000. So pi is going to equal, pi the profit is going to equal 21,333.31 minus 96,000 plus 128,000 minus 10,000 equals $43,333.31. Not a bad amount of profit if you ask me. And we are done with this problem. It only took us 9 minutes.